All right, so we're going to look at the next couple of sections in chapter 3. Section 3.1 is complex numbers, and section 3.2 is quadratics. And I'm also going to pull up the calculator too. All right, so we're just going to review complex numbers. And I believe this was in 102. For complex numbers, okay, we'll first talk about the standard form of complex numbers, and the standard form for complex numbers would be in the form a plus bi, right, where a would be your real number, b would be the coefficient for your imaginary unit I, and just where this I comes from, I'm going to just go back to square roots for a second. So if we have the square root of 4, right, the square root of 4 is actually plus or minus 2, right, which means that if we take a positive 2, square that, we get a 4. If we take a negative 2, square that, we also have a 4. Here is where imaginary numbers come in. Right, so something like this, the square root of negative 4, it's actually not a real number, so this introduces the imaginary I unit. So as far as the imaginary I unit is concerned, we set this construct that I squared is equal to negative 1. Right, so this is what this allows us to do. So in order to simplify the square root of negative 4, I can actually write the square root of negative 4 as the square root of 4 times the square root of negative 1. All right. So from our construct, I square is equal to negative 1. All right, so I can write this as two I, right? Because if I multiply I squared, I times I would actually give me I squared, which would be a negative 1. All right, so the square root, so I squared is equal to negative 1. So that's our basic construct. For as far as this calculator is concerned, try to shrink this down some. All right, I'm going to go into mode for just a second. Well, I'm going to turn it on first. All right, and I'm going to go into mode, and where is it? The next to the last one, I have real. I have a plus bi, and then I have this r times e raised to the theta I. If our calculator is in real number mode, I can put in the square root of 4. I should get 2. I can put in the square root of negative 4. So notice I'm using minus and not the negative. Right, and notice I get that that's not a real number, right? Because I is an imaginary construct, right? That's actually not a real number. However, if I go back into mode, I'm going to change from real number system to A plus BI, which is this complex number system. Okay, so what this is going to allow us to do is actually perform operations with complex numbers. So now notice I put in the square root of -4, I get a 2i, right? So the 2i, I is the imaginary unit. If your calculator is in A plus BI, which is the complex number system, it will in fact give you the square root of a negative number. All right. So as we're looking at the problems that are in section 3.1, hey, we can actually do these same operations on the calculator. All right. So just to show where that imaginary unit I comes from. Next, we're going to perform operations with complex numbers. Okay. And in this first example, we're going to actually add or combine complex numbers. So we have 3 minus 5i plus -2 plus 2i. Okay, so we want to take these two numbers that are in complex number form and we want to combine them. So just as in real numbers, you can only add or subtract like terms. So in order to do that here, I'm just going to remove the parentheses and combine like terms. So if I look at this first set of parentheses, I have 3 minus 5i. So keep in mind that there is an imaginary 1 in front of that parenthesis. In order to remove the parenthesis, I can distribute, right, 1. And that's basically going to remove the parentheses, and we have 3 minus 5i. I'm also going to move the set of parentheses from that second term. So here again, I'm going to distribute positive 1. Right, so we have -2 plus 2i. Right, I'm going to combine like terms, and I'm going to keep this in standard form. So I'm going to combine my real numbers. 3 minus 2 is 1. I'm going to combine my imaginary units. -5 plus 2i is -3i. So we have 1 minus 3i. Right. Now I can also perform the same operation using a calculator. And so I'm basically going to enter it exactly as I said, a parenthesis 3 minus 5i. And I is located above 1 on my calculator. No, it's located above the decimal point on my calculator, and it's a yellow function. So I'm going to hit second and the decimal point. Okay, so that's how we can actually recall the I. Plus, okay, I'm going to put another begin parenthesis, negative. So I'm going to use a negative and not the minus. 2 plus 2i. All right, and if I hit enter, I get 1 minus 3i. So keep in mind, in order to perform these operations, your calculator must be in complex number form. Next, we will multiply. And this is 5 plus 4i times 4i. Right, so we're actually multiplying a binomial times a monomial. So I'm going to distribute 4i. All right, so 5 times 4i is 20i. 4i times 4i is 16i squared. All right, just remember from our rules for exponents, a to the m times a to the n is a to the m plus n. All right, so whenever I have like bases, okay, so whenever I have like bases, I will add my exponent. So notice I multiply I times I. My base is I, but each one of these i's carries an understood one as an exponent. Right, so I times I is I squared. Now this is going to become important later on, so I'll go through a couple of these exponent rules. We have another exponent rule which says that a to the m times a to the m raised to the power of n, we would multiply exponents. So we would have a to the m times n. So here's an example. I squared to the 10th power. Right, I would multiply 2 times 10, so that would give me I to the 20th power. And keep in mind in fact that I squared is equal to -1. So now this is actually the fact I'm going to use here. So I have 20i plus 16i squared. So I'm just going to rewrite I squared as -1. I'm going to put this in standard form. So 16 times -1 is -16. And so remember, when we put complex numbers in standard form, we must put the real number first. Plus 20i. All right, so now I'm going to check that on the calculator. Right, 5i, no, excuse me, 5 plus 4i. Okay, times 4i. So I'm just using parentheses. The calculator understands parentheses as multiplication. All right, and we get -16 plus 20i. All right, so next we're going to take a look at division. Okay, so here we have to simplify. 5 minus 4i divided by 2 plus 4i. So in simplifying this rational complex number, we have to talk about something called the conjugate. So conjugate pops up in radicals, they also pop up in complex numbers. So a conjugate, and let me give myself a little bit over here. Right. So for example, let's say we have 2 plus 4i. We have negative 2 plus 4i. Negative 2 minus 2i. All right, so we'll just take these numbers. So the first number is 2 plus 4i, and we simply want to find its conjugate. The conjugate only changes the sign of your imaginary number. So the conjugate for 2 plus 4i would be 2 minus 4i. The first number, the real number, stays the same. The only sign that changes is the imaginary unit. So if we look at that second term, negative 2 plus 4i, its conjugate would be negative 2 minus 4i. And if we look at the third complex number, negative 2 minus 2i, its conjugate would be negative 2 plus 2i. All right, so when you're finding the conjugate, you only change the sign of your complex, and you only change the sign of your imaginary number. All right, so now this is where this comes into play. So we have 5 minus 4i divided by 2 plus 4i. So when we simplify, much as when we simplify radicals, when I say simplify radicals, normally in the denominator, okay, we only want whole numbers. We don't want this imaginary unit in the denominator. So I'm going to multiply the numerator and the denominator by the conjugate of the denominator. So if I look at my denominator, it's 2 plus 4i. So the conjugate of 2 plus 4i is 2 minus 4i. So I'm going to multiply the numerator and the denominator by 2 minus 4i. So that's the first thing. I'm only taking the conjugate of the denominator. And now if you look at the 2 minus 4i over 2 minus 4i, anything over itself is 1. So anytime you multiply something by 1, you don't change the value, but you can change the way that your number is expressed. All right, so here we're just basically multiplying by a special form of 1. So I'm going to multiply the numerators, and I'm going to use a distributive property. So what I mean by that is I'm going to take 5, which is in the 5 minus 4i, and I'm going to multiply 5 times 2, and I'm going to multiply 5 times negative 4i. So 5 times 2 is 10. 5 times negative 4i is minus 20i. Right. I'm also going to distribute negative 4i. I'm going to multiply negative 4i right by 2. And I'm going to multiply negative 4i by negative 4i. So negative 4i times 2 is negative 8i. Negative 4i times negative 4i, well, a negative times a negative is a positive. 4 times 4 is 16. I times I is I squared. And I'm going to simplify that in just a second. And then I'm going to do the same thing to the denominator. I'm going to multiply 2 plus 4i times 2 minus 4i. All right, so the same thing, I'm going to multiply everything by 2. So 2 times 2 is 4. 2i times negative 4i is negative 8i. I'm going to distribute 4i. So 4i times 2 is positive 8i. 4i times negative 4i, well, a positive times a negative is a negative. 4 times 4 is 16. I times I is I squared. All right, so now we're going to simplify. So in the numerator, I'm going to bring down 10. Negative 20i minus 8i is negative 28i. Remember that I squared is negative 1, so 16 times negative 1 is minus 16. If we look in the denominator, the 8i's are going to cancel. I'm going to bring down 4. And I have negative 16 times I squared. Right, so keep in mind that I squared is negative 1. So negative 16 times negative 1 is positive 16. Right, so just keep the fact in mind that I squared is negative 1. All right, so now I'm going to combine, well, simplify the numerator. 10 minus 16 is negative 6. Minus 28i. 4 plus 16 is 20. All right, now from this point, I want to simplify, but I want to use this formula, right? It's divide by a monomial, and it says that a plus b over c, that's equal to a over c plus b over c. Right, which means that I want to rewrite the denominator as a denominator for every term in the numerator, and then I'll simplify. Right, so since I only have one term in the denominator, right, I'm going to rewrite this as negative 6 over 20 minus 28i over 20, and now I'm going to simplify. Right. So negative 6 over 20, that reduces down to negative 3/10 minus 28 over 20. We can reduce both of those by 4, so we have minus 7/5 I. All right, so we're going to try this with the calculator. All right, so just to go back, well, All right, so just to go back, we took 5 minus 4i over 2 plus 4i. We multiplied the numerator and the denominator by the conjugate. Right, and there was a fair amount of math in there. Right, so we basically multiplied two binomials. We simplified. We had to keep in fact in mind that I squared is -1. Can we reduce down on the end? Right, so I'm just going to check this with the calculator. Right, so I am going to carefully put this in. I'm going to put the numerator inside a set of parentheses. Okay, and I'll just show you what happens if you don't put it inside a set of parentheses. The calculator won't actually follow order operations. Right, so I have 5 minus 4i. Right. I close off my numerator, divided by, I'm going to open up another set of begin parentheses for the denominator, 2 plus 4i. All right, so notice I get -0.3 minus 1.4i. I can actually change these to fractions. So I'm going to hit math. Okay, the very first option says it'll take what it's given, it'll try to convert it to a fraction. So I'm going to hit enter once. Okay. And the calculator is freezing. So I'm going to try that again. Okay, I hit it once, I hit it again, and we have -3/10 minus 7/5 I. All right, so we looked at how to do it both by hand and on the calculator. All right, now for this last set, okay, this is something that we can actually do on a calculator. All right, so you'll be asked to simplify I raised to some power, right? So the possible answers here are negative I. It could be positive I. Believe you can have negative and +1 as your answers. So this is what I mean. If I were to just put this into the calculator, I raised to the 23rd power. I don't know what it's going to give me. It gives me like 3, and this e that you see is times 10 to the -13 minus I. All right. So these are about the only things that you can actually do on the calculator. So we got to simplify these by hand. All right, so we're asked to simplify I to the 23rd power. We're going to have to keep in mind a couple of rules for exponents. This is the first one. A to the m times a to the n is a to the m plus n. This is 1. And a to the m raised to the power of n is a to the m times n. I also want to keep in mind that I squared is -1. So I'm always going to start with I squared. So I'm going to set this equal to I squared. Now I'm going to have to build this up until I get to an I to the 23rd power. All right, so if I have I squared, if I were to multiply that by 10, I would have I to the 20th power. but I actually need I to the 23rd power. So I'm going to add I to the third. So that's actually like I to the 23rd power in disguise, because if I have, just to check what's going on over here, I squared raised to the 10th power, that's I to the 20th by using this formula. Right? And then I have I to the 20th times I to the third. I would add the 20 plus 3 to get I to the 23rd power. Right? So I'm going to simplify it down from this point. So keep in mind that I squared is -1. So I'm going to change I squared to -1. Right? If I were to take -1 and raise that to the 10th power, that would actually give me a +1. Right? Because if I take -1 times itself 10 times, that will reduce down to give me a +1. Right? So the 1 is understood. So now if I break I to the third power down a little bit further, I can rewrite I cubed as I squared times I. Right? Because I squared times I to the first power, I would add the 2 plus 1, which would give me I cubed. So on the last step, I know that I squared is -1, so I would simplify I to the 23rd power. That can be simplified as -I. So when you're simplifying the powers of I, there should only be 4 answers. One of the 4 answers could be I. These are the possible answers. I, -I, 1, -1. All right, and those are the only problems that you can't actually do on the calculator. All right, now speaking of the calculator, as far as your calculator is concerned, turn this back on. It doesn't really matter if your calculator is in real number format or imaginary format. Okay, the only difference is that if you're in the complex number format, it'll recognize negative radicals and imaginary I, and it won't let me turn it on. But normally after I work with complex numbers, I'll change it, and then after I'm not working with complex numbers anymore, I'll just revert it back. Okay, but it won't actually hurt anything in the course if you leave your calculator in the A plus BI mode. All right, so next we're going to look at quadratics. And for a quadratic equation, it is in this this is the most basic form. Y is equal to x squared. And when you graph a quadratic equation, there are one or two graphs it can produce. It can either produce a U-shaped graph, or it could produce an upside down U-shaped graph. Now there's something special about these, and these are called parabolas, right, or U-shaped graphs. All right, they actually bend. The point at which these graphs bends, those are called the vertex. All right, now it's in the majority of the problems in section 3.2, you're going to be asked to find the vertex or the coordinates for the vertex. So you're going to be asked to locate the coordinates in which these parabolas bend. So we're going to look at that in a couple of methods to find the vertex. So find the vertex. And let me just check something real quick. I don't believe they are asking us. Okay, we'll actually find it. We'll look at it three ways. So we're asked to find the vertex. Here is the first method. And it's actually by a formula. So the vertex is negative b over 2a and f of negative b over 2a. And I don't believe you actually have to do this in the problems, but I'm going to just show all three ways. All right, so this is the first way by using the formula. Negative b over 2a, comma, f of negative b over 2a. So here's the quadratic equation we're going to use. P of x is equal to x squared plus 6x plus 10. And we're asked to find the vertex. So I'm going to use this formula, negative b over 2a, comma, f of negative b over 2a. All right, so first off, for this quadratic equation, right, remember quadratic equations are in the form ax squared plus bx plus c. So a is simply the coefficient of your squared term, so a is going to equal to 1. B is going to be the coefficient of your middle term, so b is equal to 6. C is going to be the coefficient of your last term, so c is equal to 10. Now we don't actually need c for the vertex formula, but I'm just going to write out all of our coefficients, right? So first I'm going to find the x coordinate of our vertex, negative b divided by 2a. So that's the first thing. Find negative b over 2a. So I'm just simply going to substitute. So I have negative, which is from my formula, b, which is 6, right, from the quadratic equation, over 2 times a, which is 1. So I have negative 3. Right? So that would be the x coordinate of the vertex. So let me just make that stipulation. This is the x coordinate. Okay. I just simply use the first half of this vertex formula, negative b over 2a. Right, I substituted b for 6, a for 2. Right. Simplified it, we got negative 3. The second thing we're going to do is find the y coordinate. So this is how you find the y coordinate. So up here is like f of negative b over 2a. We already found negative b over 2a as negative 3, right? So I actually want to find f of negative 3. Right? So in order to find f of negative 3, I'm going to go back to my formula, right, which is x squared plus 6x plus 10. And wherever I see an x, I'm going to substitute it with negative 3. Right, so this is negative 3 squared plus 6 times negative 3 plus 10. Negative 3 squared is 9, positive 9, minus 6 times 3 is 18, plus 10, which is 19 minus 18, which is 1. So if I put the two together, my vertex should be negative 3, comma 1. So we're actually going to see the vertex in a second. So we're going to calculate this 3 ways. This is the first way. It's a mathematical way to do it, right? But nonetheless, we can find the vertex, negative 3, comma 1. The second method I'm going to use is the calculator. So method 2 is the calculator. And I'm going to use the same equation. X squared plus 6x plus 10. Now, the only thing you need to know on the calculator is you need to know the shape of the quadratic. So there's only 2 shapes, right? If we were to graph this function and we have a U-shaped curve, that's called a minimum. If you graph your quadratic equation and it forms a hill shape, that's a maximum. Right? So these are 2 things you're going to know if you use a calculator to find a vertex. All right, so let's find the vertex using the calculator, right? We know we should get negative 3, comma 1. So the first thing I'm going to do is turn the calculator on, and I'm going to go to y equals. I'm going to clear out the function that's in y equals, and I'm going to put in x squared plus 6x plus 10, x squared plus 6x plus 10, and I'm going to graph. I'm going to use zoom 6 to graph. All right, so far so good. I just put the equation into y equals and I graphed it. And now just notice the shape it produces. Right, so that since the curve forms a U shape, this is actually the graph of a minimum. So here's the reason why you need to know if it's a maximum or a minimum, because in the calculator, there is no vertex function. All right, you either find the maximum or the minimum. So now I'm going to go into calculate, right, which is above trace. So it's second in trace, which is calculate. I want to calculate the minimum. All right, so that's why it's important to graph, and it's important to realize if your graph is a minimum or a maximum. Right, so I'm going to calculate the minimum. I'm going to hit enter. And then it's going to ask for three things. It's going to ask for a left bound. It's going to ask for a right bound. It's going to ask for a guess. So here's what left bound means. It means that you must physically set a point to the left of your vertex. So I'm going to just use my cursor, right? And I can actually see it on my screen, right? I want to move my cursor to the left of my vertex. So notice it bends here. I've now moved my cursor to the left. I'm simply going to hit enter. And then you notice on your calculator, it should pop up, a sideways triangle should pop up that falls to the left of your vertex. Now the calculator asks for a right bound. So I'm going to move the calculator to the right of the vertex. I'm going to hit enter. And notice it should pop up another sideways triangle, but this time it falls to the left of your vertex. It asks for a guess. So for a guess, I'm not moving to the left or to the right or anything. I'm simply going to hit enter again. And it should give you the coordinates for the vertex. And I do have a video for this calculator stuff. I'll put it on the announcements page. So notice we got the same vertex we just calculated by hand, -3, 1. So that's two ways to find the vertex. Here is a third way to find the vertex. And it's by writing it in this form. So P of x is equal to x minus h quantity squared plus k. If your quadratic equation is written in this form, you can pull out the vertex as h comma k. So in section 3.2, you'll be given a quadratic equation that's written in this standard form. You'll have to rewrite it in this vertex form, and then you can pull out the vertex. So I guess it's kind of double-sided. You can find the vertex by using a calculator, you can find it using that formula we first talked about, or you can find it using this equation. The only way you can find this equation that they want, because in the problems they'll ask you for the equation written in this form, and then they'll ask you for the vertex. So what we're going to do from this point is we're going to take this equation, right, x squared plus 6x plus 10. We're going to write it in this form, right? P of x is equal to x minus h quantity squared plus k. And from that form, we're going to pull out the vertex. All right, so we have P of x is equal to x squared plus 6x plus 10. So I'm going to call this the vertex form of a quadratic. Right, so we want to take this equation that's in standard form and write it in this vertex form. So we have to do something called complete the square. All right. So we want to write in vertex form. So the first thing we want to do is complete the square. And I also have a video on completing the square. Just like I go through the same thing, I think I do 2 or 3 other examples. All right, so when we complete the square, you must have the proper form in order to complete the square. So we're going to isolate the second degree term and the first degree term. So I'm going to isolate them by putting them in a set of parentheses. Okay, so now this is a basic problem. So what I mean by basic is there are some understood things that's going on. So when you isolate your squared term and your first degree term, so when I say squared term, I'm just saying that the squared term is the variable that's squared, and the first degree term is the variable that has the exponent to the first power. The coefficient of your squared term must be 1. So I do an example in the video where the coefficient of the squared term is something other than 1. All right, but just introducing this, all right, I have the right form. All right, so the only thing I did was I used 2 sets of parentheses, but if I look at everything I have x squared, I started with x squared. I have 6x, I started with 6x. I have 10, I started with 10. So I haven't added anything to this equation. So I'm going to complete the square. So in order to complete the square, we have to take half of the coefficient of the middle term So the coefficient in the middle term is 6. We have to take half of that. So I'm going to take 6. I'm going to divide it by 2. And then I'm going to square it. take half of the coefficient of the middle term squared and square it. So this is basically what it means to complete the square. So if I take half of 6, I get 3. And if I square 3, I get 9. Whenever you complete the square, you force what's called a perfect square trinomial. All right, so is everybody clear with that step? I isolated the second degree term. I isolated the first degree term. Had to make sure the coefficient of second degree term was 1. I took half of the coefficient of the middle term and squared it. But I want you to see something. Since we completed the square, we added something that was not originally added. Well, that was not original to our problem. All right, so here's what I mean. X squared, I started with x squared. 6x, I started with 6x. I started with 10. But when I completed the square, I added 9 to the right-hand side. So from the properties of equality, whatever you do to one side, you must do the same thing to the other side. So since I added 9 to the you gotta be kidding. Okay. Since I added 9 to the right-hand side, I must also add 9 to the left-hand side. Right. Whatever you do to one side, you must do the same thing to the other side. So now I'm going to take the 9 that I just added to the left-hand side, and I'm going to move it to the right-hand side. So I'm actually going to subtract 9. I'm going to rewrite x squared plus 6x plus 9. Right, since we completed the square, we forced the perfect square trinomial. If I were to take x plus 3 times x plus 3 and FOIL that out, I would get x squared plus 9. And then 10 minus 9 is 1. So this is actually the equation that they're looking for. This is P of x is equal to x plus 3 quantity squared plus 1. So that would be the first half of the problem, right? You'll be given the quadratic in this form, right, which is standard form. You must then complete the square and put it in this vertex form. From this vertex form, you can pull out the vertex. So notice now we kind of worked this vertex thing out. We got -3, 1, right? Which was the vertex from earlier. If I go back up to this vertex form, this is what you have to be careful on. Notice that when you pull the vertex out from this vertex form, the x coordinate is going to change signs. So notice in this general form up here is p of x is equal to x minus h quantity squared. But once I take the negative h out of the vertex form, the sign changes. And then whatever our coefficient for k is, that stays exactly the same. So if I look at this form, notice that I have my h is positive 3. And then notice when we worked it out, earlier we got a negative 3. When you take your vertex out of this vertex form, be mindful that the x coordinate will change signs. The y coordinate is going to remain the same. All right. And we will do one more. Let me just pull up a problem from the homework. Question?
In the homework, what does it mean when it's saying y equals blank x minus blank squared? What they put in there?
Like right here, you would put, it wants the coefficients. So like here, you would have a 1. So instead of using p of x, they're using y. And then you would put in these coefficients. You would put a 1 in, you would put a 3 in, and then you would put a 1 in. And I believe it wants the vertex, the 3, the negative 3, and the 1. Okay, here is one. This is actually like the second one. It says 3.2, number 2. F of x is equal to 3x squared plus 18x plus 28. All right, it wants us to do the same thing. It wants us to write it in that vertex form, and then it wants us to pull out the vertex. Okay. All right, so we're going to follow the same steps we followed previous, but we got to be a little bit more careful. All right, so I want to group the second degree term and the first degree term. So I'm going to put some steps. So group second degree and first degree terms. So 3x squared plus 18x plus 28. Okay. So now this is what we did not have to worry about in that previous problem. Notice here that the coefficient for our squared term is not a 1. We have to force it to be a 1. So the way I'm going to force, and I'm only worried about this second degree term being a 1. I'm not worried about the first degree term. In order to make this a 1, I'm going to factor out 3. So the second thing is we have to force the coefficient of the squared term to be positive 1. Okay, it has to be positive 1. So I'm basically going to factor out a 3. So I have 3 times the quantity x squared plus 6x plus 28. Right? Because if I go back and multiply that 3 back in, 3 times x squared is 3x squared, 3 times 6x is 18x. Right? So now I have the right form in order to complete the square. So now we're going to complete the square. Right? So we have to take half of the coefficient of the middle term and square it. So then we get 9 again. That's not going to happen in all these cases, but just for these 2 problems I pulled up. It just so happens that you get 9. Okay, but that does not happen every time. And this is where you have to be careful on this one. All right, because we just added something that wasn't originally there, right? So 3 times x squared is 3x squared. We started with 3x squared right here. 3 times 6x is 18x. We started with 18x. That's right here. And then we also started with that 28, right? But 3 times 9 is 27. We added 27 on the right-hand side. So I also have to add 27 on the left-hand side. And then I'm going to subtract 27 from both sides. So f of x is equal to 3 times x squared plus 6x. It is like a 27 in disguise. Plus 28 minus 27. Is everybody okay with that? So notice now, I didn't just add 9 to both sides. I added 27 because 9 times 3, once you distribute, that gives you 27. So I added 27 to the left-hand side, and then I subtracted the 27 to move everything on the right-hand side. All right. So now I can rewrite the x squared plus 6x plus 9. Right? Since we completed the square, we forced a perfect square trinomial. So I'm going to write that as x plus 3. X plus 3 quantity square plus 1. So if you were to actually put that in, I think it wants you to put in something like this. Y is equal to so you would put in 3 for this first block, right? Because that would represent that 3 times x. You want to put in a minus 3 because that sign is going to change, right? A negative times a negative makes the positive that we have, but you're always going to have a minus right here. And then that last box is a 1. And then our vertex Remember, the sign is going to change for that first coordinate, so it's -3, 1.